This is the solution to homework set number 9 of EE206 Circuits 1. The first problem is given a resistor, inductor, capacitor. Find the impedance at 3 different frequencies. Here the trick, resistors don't change. At any frequency the resistance is still 100 ohms. The inductor goes as j omega L. So the impedance will be your inductance 0.01 times 20 times 200 times 2000. So inductors have a plus j impedance. Capacitors are 1 over j omega c. Plug in C as 10 microfarads, and I get minus j 5000 ohms, minus j 500, minus j 50. So kind of note, with inductors, the impedance goes up with frequency. Capacitors, it goes down with frequency. Inductors have a plus j impedance. Capacitors have a minus j. For problem number 2, given this circuit, find the impedance between A and B. The trick is first, convert to phasors. The inductor becomes J1 ohm, J2 ohms, minus J100, minus J200. And now, when I start adding these, 300 plus J2 in series is 300 plus J2, and parallel with minus J200 gives you 92 minus J138. In series, meaning add, 20 plus J1 gives you 112 minus J137, and parallel with minus J100 gives you 16 minus J65 plus 10. This is where HP calculators are very useful. They can go through these calculations with ease. TIs kind of struggle. The third problem is repeat. Here's a change the frequency and the impedance changes. So the inductors now become J10, J20. Capacitors become minus J10, minus J20. Repeat, and I should wind up with 12 minus J7 ohms. Problem 4 is write the node equations for this circuit. This is just like an resistor circuit. At each node, the current left, current right, current down, that's 0. Same thing with complex numbers. First, find the capacitor. Capacitor becomes 1 over j omega c, or minus j 1000 ohms. So now the input is 10 cosine 1 under t, so the phasor representation is 10 plus j0, 10 cosine, 0 sine. Then your node equations. Note that the node equations are just like we had before. I've got the current left, current down, current right. The only difference is I just have a complex number for one of the impedances. To solve, I group the terms just like we did for resistor circuits. Put into a matrix and solve. And I wind up with complex numbers. What the complex number means, the real part is cosine, minus j is sine. So the V1 is 8.8 cosine 100t plus 2.4 sine 100t. Likewise for V2 and V3. If you prefer polar form, you can also write it this way. Either answer is correct. Pick your favorite. I personally prefer rectangular form. If you go into Circuit Lab and simulate this circuit, I'll wind up with the same answer. Note that in Circuit Lab you get the polar form. If I look at the polar answer, it should be, say for V3, 8.9 is minus 32 degrees. The third one, this here is 10. The orange line is at 8.9, that's the amplitude, and the phase shift. One cycle is 360 degrees. Here's half a cycle, 180, 90 degrees. The orange line is delayed by 32 degrees, which is what you see here. So in lab, you typically get the polar form. In calculations, I tend to use rectangular form. They're both equivalent, so pick your favorite. Problem 6. Again, if I have this circuit, first trick is convert to phasors. The input is 10 plus j0, 10 cosine, 0 sine. Change the inductors, capacitors to their phasor impedance. Now write the node equations. At node 1, you get the current left, current down, and the current right add to 0. At node 2, current left, down, and right add to 0. Likewise at node 3. Here we just have 3 equations, 3 unknowns. Albeit, one of the equations, or all the equations, have complex numbers. But if you don't mind complex numbers, it's just like we did at DC. Throw into a matrix. Solve. To solve, you really need to use MATLAB. Solve, I get 3 numbers, each complex. Again, the real part is cosine, minus j is sine. So here's your answer. Or if you prefer polar form, either answer is correct. polar form is easier to see in lab. For example, the third one will be 8.9 volts and minus 13 degrees. If you simulate it, here's what you get. And there's the third one. It's down to 8.9 and just a slight phase shift. Again, this is 360 degrees. Here's 180. Here's 90. That's only 13 degrees. So that is this homework set for EE 206.